Okay, so number 5 now. How many four-digit numbers can be formed using only these numbers? The 0, of course, becomes key to the question because I can't start a four-digit number with a 0. So 0497 is, in our minds, at least a three-digit number. It's 497. Which means that we won't have a simple permutation with these questions, or we won't likely have one anyways. So if we look at the first one, no repeats are allowed. That means that in the first, for my first digit, I have the 3, the 2, and so on. Anything but the 0 is okay for that first digit. So I have 6 options for that first digit. Once one of those numbers is taken up, it's not allowed to be reused, but the 0 is allowed to be used for that second number. So the second digit has 6 possibilities, then down to 5, then down to 4. 720 is our answer. If we look at the number being odd and no repeats allowed, the key here is to recognize that my four-digit number, the first key piece of this is that the number has to be odd, meaning that this spot has to have an odd digit. I have the 3, the 7, and the 9 available, of course, so that means there are 3 possibilities for that number. Regardless of what has been chosen here, we know that one of those 3 numbers will have been chosen. I'll still have 2 of the odd digits and 3 of the even digits available for that first spot. The 0 again is not available. So I have 5 possibilities here. I then have the 4 remaining possibilities and the 0 here, and then of course just whatever hasn't been used in the other spots in this spot here. So I have 3 times 5 times 5 times 4, or really if I work left to right, 5 times 5 times 4 times 3. But again, it comes from the idea that the 3 options at the end were the most important. So here I had 3 options for the last digit, 5, 5, and 4. I did talk to a couple of students and give them sort of another option for this, and that would be if you start at the left side and think about the possibility that I could have had the 3, my first digit could be even or odd, and that would affect my last digit's availability. In the case of the even numbers, there are 1, 2, 3 possibilities. In the case of having an odd lead digit, there are 1, 2, 3 possibilities as well. In either case, we kind of need to sort of remember that down at the end here, I have to kind of deal with that fairly quickly. And of course, if I've used an even digit at the start, I still have 3 possibilities here. If I've used an odd digit at the start, I only have 2 possibilities here. I've got, again, 2 possibilities used up now. That leaves me with 5 other values and 4 other values in this case, and the same thing 5 and 4 here. And if we do these ones quickly, I see 9 times 20 is 180. I see 6 times 20 is 120. And those 2 things obviously add up to that same 300. So again, just 2 possibilities depending on how you want to think it through. In this case, I considered the odd digit to be at the end to be the most important thing. Starting there, the rest of it sort of took a little bit less work that way. A number greater than 4,000, no repeats allowed. So essentially, in my first spot, I now need to have a 7, a 6, a 4, or a 9. 4 followed by any other 3 digits will be greater than 4,000, and so that one's fine. So I've got 4 possibilities for that first digit. And again, regardless of what that first digit was, the 0 and all the other digits now come into play. So I've got 6 possibilities, and then 5, and then 4. So 4 times 6 times is 480. The last one might be a little bit tougher. The number is greater than 4,000 and repeats are allowed. So our first digit will start with one of those same possibilities, the 7, the 6, the 4, the 9. There are 4 possibilities there. And then in theory, any of the 7 digits is available for each of the remaining positions. And so 4 times 7 times 7 times 7 is 1372. But you want to recognize there that one of those possibilities was a 4 followed by a 0 randomly chosen, followed by a 0 randomly chosen, followed by a 0 again. And in this case, the number 4000 is not greater than 4000. So the 1372 includes the 4000, which is not really greater than 4000. So there are only 1371 possibilities. Now, card games will be a pretty popular recurring thing. I'll quickly note that on your exam and on any tests we have, I will put a deck of cards kind of showing up on the last page, so that those of you who are less comfortable with the idea of the fact that there are 52 cards total, 13 cards of each suit, 4 suits, and so on, you can kind of get that in 2 sets of red, 2 sets of black. That'll kind of be showing there, so hopefully you're comfortable with that. If you're not sort of yet, you might want to just look at a deck of cards and get an idea of what they look like. I found a surprising number of students have never used a deck of cards, and that saddens me greatly. 5 cards are dealt from a standard 52 card deck. So essentially this is your traditional poker hand. How many different hands can be dealt? Well, pretty straightforward, I think. You're looking at, there are 52 cards. I need to choose 5 from my hand, or, again, randomly chosen 5. I don't get to choose them myself. So 2 million and so on. How many hands will contain 4 hearts? So there are 13 hearts in the deck. So essentially we have to choose 4 of the hearts to be given. Now again, I say choose. As the player, you're not choosing them. They are randomly being chosen for you by the person shuffling and dealing the deck. But I'll keep using the word choose because choose implies combination. So there are 13 cards. I choose 4 of them, or 4 of them are chosen for me again. And then there are 39 other cards that are not hearts that would allow me to just guarantee that I have only those 4. I have to be careful. I don't want to get that 5th heart, so there are only 39 ways to choose that last card. How many hands will contain no face cards? So again, if you're not clear, Jack, Queens, and Kings are the face cards. And again, in each of the 4 suits, there are 3 of them, so there are 12 face cards. If they've been removed, I'm left with 40 cards. Again, 40 cards from which to choose. They haven't necessarily been removed from the deck, but they've been removed as possibilities given this restriction, and so 40 choose 5. Contain only spades or only clubs. Only spades, similar to this, there would be 13 choose 5 ways to get only spades, but there would also be that same number of possibilities of clubs, and so we have 1287 times 2 is this. Only red cards, half the deck is red, so there are 26 cards, choose 5 of them. Okay, so moving on to F, it looks like I somehow messed it up a bit here. How many will contain no more than 2 face cards? It looks like initially I handled the case of 3 face cards and 4 face cards, but somehow missed the fact that, of course, 5 face cards is a possibility as well. So, a little bit more complete a solution here. The posted solution I will change, but it was this. Actually, I guess I still want that to be showing up because it's part of my solution. But this is not quite complete at this point. So 3 face cards, the possibility where 3 face cards occurs is 12 choose 3 face cards. So of the 12 face cards that are available, choose 3 and choose 2 out of the remaining 40 cards. 4 face cards, of course, similar. And again, 5 face cards is also a possibility. And so because those are the situations that we don't want, those are the cases that go against what I'm looking for. Remember, I'm looking for how many will contain no more than 2. So these are the situations I don't want. I can subtract them, each of these 3, from the total number of hands that's available way back up here in A. Because there were 3 possibilities there that were bad, and there were only 3 possibilities that were good, of course going the other direction probably made more sense. Initially I went this way because I was thinking for some reason that there were only two negative possibilities, and it was a little bit quicker. So the other possibility here is that I look at the positive cases, the case where I have 0 face cards and 5 others, one face card, and 4 others, 2 face cards, and 3 others. And of course, they add up to the exact same number as you would hopefully expect they should. G, how many will contain at least 2 hearts? So this is the final of the cards questions. I'll slide it up here. At least 2 hearts means we could have 2, 3, 4, or 5 hearts. Or again, we could look at the other possibilities. The situation we don't want is only 0 or only 1 heart. And because there are only 2 calculations there, it's probably the little bit nicer way to go about things. So 0 hearts would be, again, there are 13 cards that are hearts, so 39 cards that are not. 39 choose 5 is that many possible hands without any hearts. This is the number of possibilities of hands with 1 heart, so 13 choose 1, and then 39 choose my 4 other cards. And of course, 2 or more would be all of the other situations. So as we saw last time, take the total number of hands possible, subtract the 2 that are not of interest to me, and I'm left with this many hands that contain 2 or more hearts. Okay, so last one, number 7. A student is asked to answer 7 out of 10 questions on a test. How many different ways can that selection occur if there are no restrictions? Well, basically you're just looking at 10 questions available, choose any 7, and that's 120. It doesn't matter the order in which I choose them. I can choose to start with number 1, then do 2, 3, 5, 7, 9. Look at question 10 and decide, ooh, I don't really like question 10. I'm going to come back and do question 4 after all. I thought I would skip it, but I'd rather try it than number 10. I still end up doing the exact same 7 questions, so it doesn't matter the order here at all. In the second part now, there are 5 questions that must be answered. So you can sort of think of this one as if questions 1 through 5 on the test are must do, and questions 6, 7, 8, 9, 10 are pick 2 out of those ones. Well, in that case, this first part of the question, or this first group of 5 questions, doesn't even come into play. So now essentially I have questions 6 through 10, there's 5 of them. I have to pick 2, and so it's simply 5 choose 2 is 10. And that's kind of what this says here, hopefully. 5 non-mandatory questions from which to choose 2. The other ones are not of interest to me. So those are the questions. Obviously some of them will have gone better than others. The thinking that you have to do in each case, of course, changes, and that's kind of the key to this, to the rest of this course, not just this section of the course. A lot of the time you'll be sort of thinking through what the question's asking as much as what how to do the math of it, and then kind of recognize, are there different situations? How do I reword this? It's a sort of an exercise in English as much as anything. If there are 5 questions that must be answered, that means essentially those questions that must be answered don't even come into play as far as the choices go later on.